It's time for fun with math, and today we're going to talk about inverse trigonometric expressions. So it turns out there are 6 trigonometric expressions, so there actually turns out to be also 6 inverse trigonometric expressions. There's the sine inverse of x, there's the cosine inverse of x, and then there's the tan inverse of x. And of course they're sort of partners over here, so the partner to sine is cosecant, so there's cosecant inverse of x, and then secant inverse of x, and tan inverse of x, or sorry, cotan inverse of x. So these are thought of as the inverse trigonometric expressions. And what do they mean? So let's look at this question. What does cosine inverse of 1/2 mean? Let's try to make sense of that. And if you have a calculator, you can take it out. And you can see that there is a cosine inverse button on your calculator. It's right behind the cosine button. Now you have to be careful because a lot of times students will think that this right here means 1 over cosine of x. But it actually doesn't. Remember, 1 over cosine of x, we have a way to express that. That's the secant of x. So this is actually the inverse function, or the inverse expression for our case right now. And the idea is it sort of undoes the cosine expression. So let me give you an example. So here on your calculator, let's put ourselves in degrees. So hit mode and get into degrees, because then we can interpret this in a little bit easier. And then hit second cosine, and let's type in 1 divided by 2. And what you're going to get back is 60. And 60 is the angle. So what this is doing, it's saying, hey, this angle here, 60, if you take the cosine of it, it's going to give you 1/2. And we can kind of draw a picture of this if you want. So over here, you have this sort of cosine inverse of x. And it's taking 1/2. You're plugging 1/2 into it. And it's taking us over here to 60. So we have some numbers over here. And it's bringing us to this angle over here. And of course, if you take the cosine of 60, it'll take you back to 1/2. So you take the cosine of it, it'll take you back to 1/2. And so you can see that the cosine inverse of 1/2, what does it mean? It's giving you an angle, right? The angle that if you take cosine of it, you get 1/2. And you can repeat this exercise. So like suppose you took second sine, so sine inverse of, and what do you want to do? Let's do 0.35. So sine inverse of 0.35. It's going to give me the angle 20.48. So if you took the sine of this angle, it'll give you 0.35, and you can even check it. So sine, second answer, you get out 0.35. And you can even do it with tan. So second tan inverse, and let's do second tan inverse of 5. Okay, so you get out an angle 78.69. So if you take the tan of that angle, it's going to give you out the number 5. And so that's what these sort of inverse trigonometric expressions actually mean. And so what are inverse trigonometric expressions? How can we understand these things? Well, the key is what? The key is this. They are angles. So whenever you see a cosine inverse, sine inverse, or tan inverse, think those are really angles. And if you think like that, most of the problems that we work on aren't too bad. Back here, we're not going to talk too much about these 3 inverse trigonometric expressions, although we can define them. We're going to focus mostly on the big 3 because these are used the most. These are used most often. All right, so let's start with working with trigonometric expressions, and we're going to start easy. Let's just work with the calculator. So take out your calculator. We'll put our calculator back into radians, even though we understand things better in degrees. You know, we want to move away from that arbitrary degreeness and move into radians. So put your calculator back into radians, and then hit second quit. And we're going to do sine inverse of 5/7. So you second sine to get the sine inverse, and then 5 divided by 7. And then we hit enter, and it spits out our angle in radians. And so to 2 decimal places, this is about since the third decimal place is 5, that'll become a 0, and that'll become an 8. So 0.80 approximately. This is approximately 0.80. Whereas down here, tan inverse of negative 56. So second tan, both the tan inverse, negative 56. Hit enter and it spits out the angle negative 1.55 approximately radians. So here we'll write approximately negative 1.55. And so remember what it's getting you out, it's not just any old number, it's an angle you're getting out. So if you took the sine of 0.8 radians, you get out 5/7. If you took the tan of negative 1.55 radians, you get out negative 56. All right, so that's how we work with inverse trigonometric expressions with a calculator. But of course, we want to get used to doing these by hand, basically algebraically. So let's look at the next set of problems. And on these, the key is, remember what these inverse trig expressions are. They're actually angles. And that, if you understand that or remember that, these problems aren't too hard. So when I look at this and I try to make sense of it, cosine inverse of 1/2, I have to remember this is actually an angle. So I'm going to set it equal to an angle, theta. And then what I can do is, since I have trouble working with this cosine inverse, I can actually take the cosine of both sides. So I'm going to take the cosine of both sides. So I have cosine of cosine inverse of 1/2. And that's going to be equal to the cosine of theta. So it's just an equation of the same operation of both sides, cosine of both sides, but something nice happens. When you take the cosine of a cosine inverse, they undo each other and leave you with what's left over on the inside. So here, I'm going to just get simply 1/2 on the left is equal to cosine of theta. And so all I need to do now is to just solve this equation. And we've solved these equations before. So remember how this works. We're going to do this, all students take calculus and find out where the angle lives. So all students take calculus. Because 1/2 is positive, I can immediately eliminate this quadrant and this quadrant, because cosine in these two quadrants is negative. So I'm either in this one or this one. Now either one would be a good choice, but the way the cosine inverse is going to be defined, you have to choose one. And so you always choose the best one. So if you think about which is the best quadrant between this one and this one, hopefully you're like, this one's the best, and so I don't need to worry about this one. So I'm going to put my angle in the first one, and we'll talk more about why this is the case later. But you want to choose the best quadrant, basically, that's left over. And so this is going to be your theta. And then to figure out what theta is, we can use that reference table. So let's make that reference table to practice it. So you have 0 radians, pi over 6, which is 30 degrees, pi over 4, which is 45 degrees, pi over 3, which is 60 degrees, and then pi over 2, which is 90 degrees. And we want to make sure we know the sine of our angle, and then also the cosine of our angle. And we just have to remember 1. Right, so the first one, sine of 0 is 0. So it goes root 0, root 1, root 2, root 3, root 4, and then remember these are all divided by 2. So divided by 2, divided by 2, divided by 2, divided by 2, divided by 2. And of course the cosine of these angles is the same, but you just write it the opposite way. So square root of 4, square root 3, square root 2, square root 1, square root 0, and these again are all divided by 2's. All right, so this angle theta here, what is it? So you look for 1/2, and you find 1/2 right here, so it must be pi over 6. This must be equal to pi over 6. And so our theta is equal to pi over 6. And so our answer here is just simply equal to pi divided by 6. Oh, hold on. I made a mistake. I looked in the wrong row, right? So I need to look in the cosine row. I looked in the sine row. So scratch that. My angle here is actually, here's the 1/2. It's actually pi over 3. So if you caught that mistake, good. I just caught it. So that should be pi over 3. And so our angle is pi divided by 3. And so our answer here would be pi divided by 3. And we can even check our work. So what's nice about this is on this type of problem is we can check our work on it. So you just take second cosine and type in 1 divided by 2. and you see it's equal to this number. Now the question is, if that is that pi over 3, so let's check it. So second raised to, pull to the pi button, and divide by 3, and you see your answer checks. All right, so then the next one, right? So on the next one here, we want to do sine inverse of negative root 3 over 2. So now remember, the trick or the idea is that this sine inverse is not just anything, it's actually an angle. So we'll set it equal to an angle, theta, and then to work with the sine inverse, we'll just undo it. So we'll sine both sides. We'll take the sine of sine inverse of negative root 3 over 2, which is equal to sine this side, sine of theta. Now remember, the sine of sine inverse, they're going to undo each other, and so they just kind of cancel in a way because they undo each other, and you just get left over with what's on the inside. So you get negative root 3 divided by 2 is equal to the sine of theta. And so we're left with this trigonometric equation, and to solve it, we do what we always do here. We write all students take calculus, so all students take calculus, and we try to figure out which quadrant this angle might lie in. And so we realize that this is negative, so immediately we can cancel the first and the second quadrant because the sign is positive in the first and second quadrant. And so it's either in the third or the fourth. Now you have to choose one. And so remember, we're starting here along the x-axis, and the best one according to the x-axis, or the closest one, is C. So that's the one we're going to pick. And in fact, whenever we're working with inverse trig expressions, we'll never be in this quadrant down here, so you can always exit out. So this is the best quadrant when you start here, and so our angle, theta, must be right down here. So that's our angle, theta. And so to find theta, again, we go into our table, and we're going to look for root 3 over 2, and this time I'm going to be careful. I'm looking for the sign, so I'm up here. Here's root 3 over 2, and oh, again, we get pi over 3. And so this angle must be pi over 3, and it's going down, so we make it negative pi over 3. And so our answer here for theta would be equal to negative pi over 3. And again, we can check our work, which is nice. So if we make a mistake, like if you thought it was positive pi over 3, we'd check your work and see you're wrong. But we'll check our work here. So you just take negative sine, or second sine, so you get sine inverse. And we type in negative second square root of 3, kick it out of the square root, divide by 2, in parentheses, and we get this number, which you can see is negative the number before it, so our answer is right, negative pi over 3. And I guess I should write that above here. This is equal to negative pi over 3. Okay, so moving on, we have one other type of problem that we want to do. And so it says we want to use a right triangle to solve each expression. So we're going to start with part A. Part A is actually a little harder than part B in a way, because you have to determine which quadrant you're in. But first, remember the sort of secret, like the trick, or the real idea is that this thing right here is not just anything. Cosine inverse of negative 1/4 is an angle. So we're going to write this as tan of theta, where theta is equal to cosine inverse of negative 1/4. And so to figure out what tan of theta is, what we're going to do is first try to figure out how to work with this. And so the idea is you can't work with cosine inverse, so again, you cosine both sides. So do cosine of theta on the left. We'll cosine on the right, cosine of cosine inverse of negative 1/4. And of course, the cosine inverse undo each other, and you're left with cosine theta is equal to negative 1/4. And so this we can use now to determine where theta, which quadrant theta is in. So again, we'll do our old all students take calculus. So all students take calculus. We have cosine theta being negative 1/4, and so that rules out which two quadrants. I think it rules out what the first, because it's positive here, and then the fourth, because it's positive there. And remember, we're working with the cosine inverse, so you're going to get just one angle back. And so you have two choices here. Remember, you're always going to choose the nicest. So starting here, the nicest would be right here. And in fact, I told you you're never going to use this third quadrant when you work with inverse trigonometric expressions. So here's the angle. We start in standard position. This must be our theta here. So there's our theta. And we know that cosine of theta is equal to negative 1/4. Now, I can't figure out the angle really because this angle is not in my reference table, but I don't really want the angle, notice. Notice I just want tan of the angle. So what I can do is I can make a right triangle here, right, using this ray basically, right? So we make our right triangle. I know SOHCAHTOA, so I know SOHCAHTOA. And so I can actually figure out the sides of this right triangle because I know this one, cosine of theta, is equal to negative 1/4. So the top is the adjacent and the bottom is the hypotenuse. And so it goes -1, that's this side here. And the hypotenuse is 4. Remember, we always put the negatives on one of the legs. So -1 and the hypotenuse is always positive, so 4. And we don't know this side, we'll call it b. But I know the Pythagorean theorem, so I know that -1 squared plus b squared will be equal to 4 squared. And so I get 1 plus b squared is equal to 16. And so then b squared is equal to 15. And then when I square root both sides, I'm going to take the positive piece because I see b is in this second quadrant, and the outputs are positive in the second quadrant. So I'll take the square root, the positive part piece, I get b equal to root 15. So this is equal to square root of 15. And so now finally I can solve for this tan of theta. So remember, tan of theta is the opposite over the adjacent. So the opposite is root 15. And then the adjacent is -1. So that's equal to negative square root of 15. And so now I can check that on my calculator if I want to make sure I didn't make any mistakes. And so I can take the tan of the cosine inverse, so second cosine, and type in -1 divided by 4, in parentheses, and hit enter. And it spits out that this number, -3.87298, blah, 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 blah. And I'm not sure if that's negative square root of 15, so I need to check that. So there's a negative. Second, x squared pulls up the square root button, and then type in 15. And then they're exactly the same. So not only did I solve the problem showing all the work, but I know I did it right because I can check it with my calculator. All right, so let's do part B. Now, part B, I said, I feel is a little bit easier. It's a little bit easier because you don't have to actually worry about the quadrants, which quadrants you're in. On this one, let's start setting it up. So remember the idea, and basically all these problems, the way that you solve them is to remember that this sine inverse of x divided by the square root of x squared plus 9 isn't just anything. Remember, it's an angle, so it's tan of an angle, so tan of theta, where theta is equal to this sine inverse of x divided by the square root of x squared plus 9. And then to work with this theta, I'm going to sine both sides basically to do the sine inverse. So I'll take the sine to the left, so I get sine theta on the left. And then remember, when you do the sine on the right, the sine and sine inverse undo each other, so they go away, and you just get x divided by the square root of x squared plus 9. And I don't need to worry about the quadrants on this one, so all I need to do is make a right triangle. So I'm going to make a right triangle that has angle theta here. And then I remember this SOHCAHTOA business, so SOHCAHTOA. And because I have the sine, I know that this is supposed to be the opposite side, and on the bottom you have the hypotenuse. So I'm going to put an x on the opposite side of the angle, and for the hypotenuse here, I put the square root of x squared plus 9. And then what I want to know is this side here, because I want to find the tan, which is the opposite of the adjacent. So I need to find a. So I just set up Pythagorean theorem, a squared plus x squared is equal to the hypotenuse squared. So that's square root of x squared plus 9 quantity squared. Now if you square root, it's going to go away. So you're just going to get a squared plus x squared is equal to x squared plus 9. When you subtract x squareds from both sides, these are going to cancel, and you just get a squared equal to 9. And so we'll take the square root of both sides. It is plus or minus 3, but we're going to always take the positive part when we're doing these sort of abstract algebra type problems. Up here, it depends on what quadrant you're in. And so, but notice there's no x's involved here, really. But down here, you can just always assume that you're in the positive part. And so our a is equal to 3. And so finally, tan of theta, which is the TOA, the opposite, which is x, divided by the adjacent side to the angle, which is 3. So my answer should be x over 3. Now you can check this one too, but you do have to be a little careful at times. Although on this problem you shouldn't run into too much trouble. But when you plug in for x, you have to plug in, sort of nice numbers in a way. So let's look at this one. Let's just plug in 3. If you plug in 3, this says it should be 3 over 3, which should be 1. So let's plug in 3 here and see what happens. So it's tan, to check our work here, right? So tan of sine, so sine inverse. And we're plugging in 3, so it's 3 divided by, and then you have the second square root on the bottom, and then 3 squared plus 9. And let's just type this in. So we'll just do 3 squared plus 9. Kick it out of here, in the parentheses on sine inverse, in the parentheses on the tan. Hit enter. Now we should get out 1, and we do. And so it checks because if you put 3 in here, 3 over 3 is 1. And so I know I did this problem correct. All right, so we're almost done. The last thing we want to talk about is how do we solve trigonometric equations, so solving equations, in particular trigonometric equations in general. So before, what we've been doing is we've been solving equations kind of like sine of x equal to, let's say, 1/2. Right? When sine of x equal to 1/2, how can we do this? Well, we can look in the unit circle. Right? We can look at the unit circle if we have it, or we could use that reference table where we had to go find the reference angles. All students take calculus, the reference angles, then we know if it find all the x values using the picture basically. Now the question becomes, what if we have sort of like sine of x equal to like 1/3? Now the problem with solving this equation is that you can't use a unit circle because you don't have an output of 1/3 in the unit circle, and you can't use a reference table because 1/3 is not in your reference table. So what do we do? So let's do an example. And I took the cosine of x equal to 3/5. And so notice you can't use a unit circle because you can't see an input value, or you can't see the angle that gives you the input value of 3/5. And you can't use a reference table because 3/5 isn't in your reference table. But you can still follow the same sort of paradigm that we set up when we use a reference table. So you can figure out which quadrant or quadrants this angle is actually in. And there are going to be an infinite number of solutions, which you can check with your calculator by graphing the left and graphing the right and seeing where it intersects. So we'll start just like we've been doing. All students take calculus. Because the cosine of the angle is positive, I know I have to be in which two quadrants. So I need to be in this quadrant or this quadrant, but I can't be in these two because the cosine is negative in those two quadrants. So I can draw my angles, like I've done before, so both angles here. And I just have to figure out this reference angle. Now for the reference angle, I can't use a reference table because clearly 3/5 is not in my table. So I have to do something else. So the new thing that I'm going to do is I'm basically going to cosine inverse both sides. And that'll undo the cosine. So let's do this slowly. So I'll cosine inverse the left. So cosine inverse of cosine of x would be the same thing as cosine inverse of 3/5. And then remember, cosine inverse or cosine, in some sense they cancel. They really undo each other. So you're just left with x equal to cosine inverse of 3/5. And this most likely is your reference angle, although it may be off by a positive or a negative. So you always need to check it on your calculator. And so to check this, it's real simple. Just do second cosine inverse of 3 divided by 5. If it's positive, it's your reference angle. If it's not, we're going to make it positive. And so it's 0.927 blah blah radians. And so I can make that my reference angle because it's positive. So that's what this thing is right here. So this is cosine inverse of 3/5. And this angle down here is the same thing, cosine inverse of 3/5. So instead of going to your calculator, going to your table, you kind of have to use your calculator to figure out, is that my reference angle? Depending whether it's positive or negative it is or it isn't. All right, so now I can read off my answers. So let's read off my answers using this picture. So the first angle is from here to here. So my first answer would simply be x equals, and I just write down cosine inverse of 3 divided by 5. And then I just add, remember I have to add 2 pi n, Because if you wrap all the way around, if I wrap all the way around here, I get back kind of where I started, and so that's another answer. And then you go to the counterclockwise or clockwise. So n is an integer. And then there's a second answer, or a second set of answers really, where you start here and you wrap all the way around to right there. Too far around. Right, I start right here and I wrap around to this angle right there. Now remember, to find this angle, the way you do it is you pretend like you wrap all the way around and you go back this angle. So this would be like 2 pi, and this would be then minus cosine inverse of 3/5. And so another way to write this down, then the second answer would be x equals 2 pi minus cosine inverse of 3/5 plus 2 pi n. 2 pi n. And n is an integer. So those are all the answers for this equation. And now you could even write this in a more compact form if you really wanted to. So if you look at the picture, you could actually write this as x equals. So the first answer is a positive cosine inverse. And you could also talk about this angle as being negative cosine inverse of 3/5. So you could actually write this as plus minus cosine inverse of 3/5 plus 2 pi n. N is an integer. That's another way to write all the solutions to this equation. But either way works. You can write it like this, you can write it like that. It really doesn't matter. All right, let's look at the next equation. And so this one is kind of the same, but it has this sort of additional statement between 0 and 2 pi. So here we have 4 tan squared x minus 9 equals 0. And we want to find these solutions on 0 to 2 pi. So first, before we even draw our picture, we need to solve this equation for tan of x. So what I'm going to do here is I have 4, I'm going to rewrite this, 4 tan squared x minus 9 is equal to 0. I guess what we can do is we just move over the 9s. We'll add 9 to both sides. So we have 4 tan squared x is equal to 9. We can divide out by the 4. So tan squared x is equal to 9 over 4. And then we'll just take the square root of both sides. So if you square root the left, you just get tan of x is equal to, and then we'll have plus or minus the square root of 9 over 4 on the right. And of course that gives us what? That gives us tan of x is equal to plus or minus, you can take the square root of the top, divide by the square root of the bottom, you get plus or minus 3 over 2. And so we really get sort of two equations out of this one equation. And so let's do each of these. So we get tan of x equal to 3/2. That's going to be one equation. And then we also get tan of x equal to negative 3/2. So that's our second equation. So let's solve both of these. And so the way that we solve these is we have to do this all students take calculus to figure out where the angle lives. So we have all students take calculus. And so all students take calculus. And we know in the first one, the tan of the angle is positive. So it can be here or here, but not over here. And so we can draw the angle. So there's our angles. One in this quadrant, one in that quadrant. Over here, it's the opposite. Since it's negative, it can't be here and it can't be there. So it's in these two quadrants. And now the idea is you want to find these reference angles here. So you want to find this reference angle here, which is the same as here. And you're going to find the reference angle here and here. And because this is not in your unit circle or your reference table, what do? Well, all you do is do the tan inverse of both sides. So we tan inverse the left. It undoes the tan and leaves us with an x. And on our right, we get tan inverse of 3/2. Same thing over here. Tan inverse both sides, and we get x equal to tan inverse of negative 3/2. Let's put parentheses around these for fun. All right, and then we can see if they're actually reference angles. If they're reference angles, remember the angles always have to be positive. So, and if they're not, we'll just make it positive. So let's just check it out. So on here, I'm going to hit second tan inverse and 3 divided by 2. And I get a positive number. So this is the reference angle. It's actually tan inverse of 3/2. And so let's write that down. So my reference angle here is tan inverse of 3/2. And then this is tan inverse of 3/2. And then we can do the same thing over here, but notice if we take the second tan of negative 3/2, you'll see it's not positive. It's actually negative. And so your reference angle can't be negative. So what we do is you usually just add a negative sign here, but we can actually see that the number above it is the positive part. And so we can just use tan inverse of 3/2 actually again in this problem if we like. So we might as well do that. So that's negative, so we're not going to use that as our reference angle. We'll use the tan inverse of 3/2 because these are the same values, disregarding the negative sign, right? And so we can use this one too over here, tan inverse of 3/2. And so what can we do? We can now use the picture and sort of read off our answers. And so if you like, over here, we could start here in standard position, just go up. And so there's the first answer. So this one would be x equals, and it would just be tan inverse of 3/2. So there's that reference angle. And then plus, now this one you don't have to add 2 pi. If you add pi, you get the other answer. So just plus pi n. N is an integer. And so that's all the answers for this one. And then over here, there are a couple ways to do this one. You can take 2 pi and take off tan inverse of 3 pi over 2, or instead of, saying 2 pi minus, you can just go down like this. So we can just say that's going to be negative tan inverse of 3/2, and then a plus pi n as an integer. You could do something like that if you like. Excuse me. All right, so, but that's not the answer. So remember, what we need to find now is we actually need to find all the answers between 0 and 2 pi. So what we want to do is simply count them off. And so we'll have x equals, and we'll let n be equal to 0. And when n is equal to 0, we just get tan inverse of 3/2. Now the question is, is that between 0 and 2 pi? Yeah, it's between 0 and 2 pi. And then we wonder if we add pi to it, what do we get? We get the second one here. So then we have tan inverse of 3 over 2, and then we add pi. And so this is that second answer, starting here, going here. But if you add another pi, if n is 2, then it goes too far because it comes back up here, so that's bigger than 2 pi. So these are the two answers that we want right here. Now when we come over here, we made the problem a little bit harder on ourselves because we went down instead of going around like this, but that's okay. So this first one, when n is equal to 0, is actually not a solution. So here, if you start out like we did over here, this was n equals 0, this is n equal 1. If you let n be equal to 0 here, you're going to get out negative tan inverse 3/2. And that's not a solution because it's not between 0 and 2 pi. You can check this on your calculator, but you can see it's a negative number, and we don't want negative numbers. We want things between 0 and 2 pi. So this is not a solution, but the next one is. If you take negative tan inverse 3/2 and you add pi to it, so then plus pi, that's going to be that first solution. Right? So you're going down, and then you're adding pi, so basically you're getting the angle that goes from right here to right there. And the second solution is going to be this negative tan inverse of 3/2 and then plus 2 pi. So when n is 2, you add 2 pi. And so this was n equals 1 and n equals 2. So if you look at the picture and try to make sense of it, you can reason this out. And you can also check this on your calculator, okay? So if you want to approximate this on your calculator, you can. So if you want tan inverse of 3/2, we can just write second tan 3 divided by 2, and you can see what it is approximately. So it's approximately like about 0.98. And then you could add pi to it, and you can get the next answer, which is about 4.12. So you can actually approximate these with your calculator if you like. All right, so let's see. Let's review here just for a moment. So what have we done? We talked a little bit about what are inverse trigonometric expressions, and the key is that they're angles. So when we work with them, we can work with a calculator, and then algebraically, all right, think of them as angles. If you do that, then most of the problems are not too difficult to solve. And then we solve some equations using these inverse trigonometric expressions. So now you can solve any trigonometric equation that's given to you. So it doesn't have to be like sine of x equals 1/2. It could be sine of x equal to almost any number here, right? So it could be like 1/5. So we don't have to rely on the unit circle or the reference table. We have a way to get around those two sort of limited types of technologies.